Imagine surviving 9 months without ever touching land, no doctor, no fresh food, no way out. Sailors face storms, isolation, even pirates, thousands of kilometers from help. What really keeps them alive out there will surprise you. In the next few minutes, you'll discover the hidden rules of survival at sea. Before we get into how we got here, comment where you're watching from, and hit subscribe, because tomorrow's story is one you won't want to miss. In the middle of the Pacific Ocean, the nearest coastline is over 1,000 kilometers away. A massive container ship keeps moving forward, steady and unstoppable, even though nobody on board has touched solid ground in months. At first glance, you'd think the biggest danger out here would be a storm, or a rogue wave crashing over the bow. But ask any sailor, and they'll tell you something different. The real test doesn't come from the weather. It comes from the sameness. Day after day, nothing changes. The same horizon. The same schedule. The same faces, repeated for weeks that turn into months. So how do people survive 9 months of near total isolation? Where does their water come from? Their food? Who treats them if they get sick, 1,000 kilometers from the nearest hospital? The answer is that life on a ship like this is engineered down to the smallest detail, and some of the rules these crews live by would surprise even people who've spent time at sea before. Picture yourself standing on the deck of a cargo giant 300 meters long. Beneath your feet, a diesel engine the height of a 3-story building vibrates without pause. Massive pistons never rest, driving a 100,000-ton hull through open water, 24 hours a day, for months at a stretch. It feels like a fortress. Sealed off from the world, self-sufficient, untouchable. But it's inside that steel hull that the real countdown begins. The first danger of a long voyage isn't physical at all, it's mental. Cut off from land, the human brain slowly loses its normal sense of time. But long before the mind starts slipping, the body faces a much more immediate threat, one that starts in a metal pipe buried deep in the engine room. You cannot simply load 9 months' worth of drinking water onto a ship and sail off. The tank alone would weigh close to 1,000 tons, enough to drag the vessel dangerously low in the water. And the ocean itself is no substitute. Seawater is lethal to drink. Its salt content pulls moisture out of human cells faster than the body can replace it, and severe dehydration can set in within about 3 days. So the ship has to make its own fresh water, continuously, for the entire voyage. The system on board works almost exactly like a kitchen kettle. Waste heat from the engine's cooling system warms seawater inside a sealed chamber. Because the chamber is kept at low pressure, the water boils at a much lower temperature than normal. The steam rises, touches cool pipes, condenses, and drips down into the ship's freshwater tanks. It's simple, elegant, and utterly essential, and it runs non-stop. But what happens when that kettle breaks down in the middle of nowhere? Crews have faced exactly that nightmare. On more than one recorded voyage, salt buildup has clogged the thin plates of a ship's heat exchanger, causing pressure to spike until a feed pump fails entirely. When that happens, the freshwater supply can drop to almost nothing within hours, while engine rooms, already running at temperatures well above 40 degrees Celsius, cause crew members to lose several liters of fluid a day just from sweat. In situations like this, engineers have improvised, rerouting condensation from air conditioning units, filtering it through charcoal, boiling it for safety, and producing hundreds of liters of usable water a day until repairs could be made. It's a reminder that on a modern cargo ship, half the crew's survival skills have nothing to do with sailing at all, they're closer to industrial plumbing under pressure. Water rationing itself follows strict, almost military logic once a shortage hits. Drinking water is prioritized first, cooking water second, and washing water is often cut entirely until the system is repaired. Engineers describe running mental math constantly during a crisis like this, liters produced per hour against liters consumed per person, factoring in the punishing heat of an engine room that can push well past 40 degrees Celsius even with ventilation running. It's the kind of quiet arithmetic that decides, almost invisibly, whether a routine mechanical failure turns into a genuine emergency or just an uncomfortable footnote in the ship's log. And desalination units aren't a luxury add-on, they're treated as one of the most safety-critical systems on the entire vessel, inspected and serviced with the same seriousness as the main engine itself, precisely because there is no backup plan if it fails for good. A ship can limp along on a damaged engine at reduced speed. It cannot sail on for months without drinkable water. Now picture opening the heavy steel door of a walk-in freezer the size of a small apartment. A wall of cold fog rolls out. Inside, at around -20°C, sit tons of meat, fish, and frozen vegetables, the entire food supply for 20-odd people for the better part of a year. If the temperature in that room climbs even a few degrees, the entire stockpile can spoil, turning a lifeline into a health hazard almost overnight. Provision holds on a cargo ship are structured like an oversized 3-tier refrigerator. The bottom level is deep freeze. The middle level stays cool for fresh produce. The top level is a dry, sealed pantry for flour, rice, and canned goods. The single biggest threat to that dry storage isn't heat, it's humidity. Let ocean moisture creep into a sealed grain store, and tons of flour can turn to mold-ridden waste in a surprisingly short time. The real crisis hits when the refrigeration compressor itself fails in tropical heat. This isn't a hypothetical. During the global port shutdowns of 2020, hundreds of cargo crews found themselves stuck at sea for far longer than planned, some for over 10 months, unable to dock anywhere. On vessels caught in that situation, cooling failures and extreme heat have forced ships' cooks into a genuine race against time, moving hundreds of kilograms of meat into whatever dry, cool storage remained, rationing every gram of food under strict daily logs, and finding creative ways to stretch supplies, growing scallions in makeshift trays in the galley, baking flatbread from the last of the flour, adding dried herbs to broth to stave off the boredom of identical meals and the early signs of nutritional deficiency. It's the kind of quiet discipline that never makes headlines, but without it, a 9-month voyage could turn into a genuine humanitarian crisis in a matter of weeks. Menu planning on a long voyage is its own quiet science. Cooks typically map out the entire trip in advance, front-loading meals built around perishable produce in the first few weeks, then gradually shifting toward canned, dried, and preserved staples as fresh stock runs low. Fresh fruit and vegetables are usually gone within the first month or two. After that, vitamin C and other micronutrients often come from canned or preserved sources, sometimes supplemented with vitamin tablets from the medical locker. Some crews keep small hydroponic or soil-based herb gardens tucked into unused corners of the galley, not for variety alone, but because the simple act of tending something living helps morale in ways a spreadsheet can't capture. Food isn't just fuel on a ship like this, it's one of the last remaining rituals that breaks up an otherwise identical day. Mealtimes are often the only scheduled moments when the entire off-duty crew sits in the same room, and cooks who understand that tend to treat the job as much as psychological maintenance as nutrition. Now imagine a sudden, sharp pain in a crewmate's side during a night watch, while the ship pitches violently in a storm. The nearest hospital is a week away by sea. There is no doctor on board. This isn't a gap in the system, it's the system. International maritime law only requires a qualified physician on passenger cruise ships. On standard cargo vessels, medical responsibility falls to the chief officer, whose only training is usually a short first aid course. Their toolkit, a stocked medical cabinet, a basic onboard reference manual, and a satellite link to shore. That link connects to something most people have never heard of, International Radio Medical Advisory Services, a system that has existed since the 1930s, staffed by doctors on permanent standby to talk untrained crew members through medical emergencies over radio or video, sometimes for hours at a time. It is nothing like the movies. Nobody performs surgery on a mess hall table with a kitchen knife and no anesthesia, that would almost certainly kill the patient. Instead, under a shore-based doctor's real-time direction, officers administer antibiotics, set up 4 drips, give injections, and manage wounds, step by step, sentence by sentence, while a doctor thousands of kilometers away describes exactly what to do next. There are documented cases of officers stabilizing life-threatening conditions this way during storms, with video signals cutting in and out every few minutes, the ship's captain holding the bow into oncoming waves specifically to minimize the rocking that would make procedures even harder, and the crew pulling a colleague back from the edge purely through calm nerves and a voice on a crackling line. For anything beyond what remote guidance can handle, the options narrow fast. A serious case can trigger a medical evacuation, a helicopter transfer if the ship is within range of shore-based aircraft, or a diversion to the nearest port if it isn't, which can cost a shipping company enormous sums and add days to a voyage. In the most remote stretches of open ocean, neither option is fast. That gap is exactly why so much emphasis is placed on prevention, regular health checks before departure, strict rules about reporting symptoms early rather than toughing them out, and mandatory first aid refreshers so that whoever is on watch when something goes wrong isn't starting from zero. On a ship, delayed reporting of a symptom isn't just a personal risk, it can become the entire crew's problem within hours. Once the storm passes and the crisis is handled, a different kind of danger settles over the ship, one that's much harder to see coming. Sit in your cabin, and the walls hum constantly at a low frequency. That's the ship's diesel engine, running without pause, month after month. In the first weeks, you stop noticing it. But somewhere around the 90-day mark, that same steady drone can turn into a slow-burning irritant that wears on the nervous system in ways people don't expect. The real psychological crisis of a long voyage doesn't usually hit during a storm, it hits during total calm. The brain, deprived of new stimulation, starts to experience what researchers call sensory deprivation. There's nothing new to look at, the same flat horizon, the same 20 faces, day after day, for 6 months straight. Denied fresh input, the brain sometimes begins generating its own signals, a well-documented phenomenon known as auditory pareidolia, where the mind imposes familiar patterns, like voices or footsteps, onto random background noise. Sailors have reported hearing their name called from an empty corridor, or knocking on a door that no one is standing behind, not hallucinations in a clinical sense, but the brain's pattern recognition system working overtime in the absence of anything else to process. To manage this, crews follow strict unwritten social codes. Respecting personal space is at the top of the list. It's not unlike working in a small shared office where certain topics are simply off limits, except here, there's no way to go home at the end of the day. Sailors learn to become, in a sense, invisible to one another during off hours, minimizing friction in a space nobody can leave. Maritime medical researchers have studied this extensively, and the consensus is that constant low-frequency vibration from the hull does measurably affect brain activity and sleep quality over time, something like a quiet speaker running under your pillow around the clock. Labor organizations have documented real cases of serious psychological strain tied to extended isolation, and the most consistent countermeasure crews report is simple, structured routine and constant technical work. A sailor who's busy maintaining machinery has far less mental space for the isolation to take root. Modern crews also lean on connectivity in ways older generations of sailors never could. Satellite internet, once a rare luxury reserved for emergency calls, has become a genuine lifeline for morale, a short video call home, a message to family, a few minutes of news from land. Where that connection is weak or unreliable, crews often fall back on older habits, shared movie nights in the mess hall, small onboard gyms, birthday celebrations marked with whatever the galley can put together, and an unspoken agreement to keep the ship's rhythm predictable, because predictability, oddly enough, is what makes an unchanging routine bearable rather than crushing. Just when the ocean feels calm again, an alarm cuts through the quiet on the bridge. A radar blip appears out of nowhere, closing in fast. Out of the darkness, 2 speedboats pull alongside the hull. A grappling hook clangs against the steel side. 100,000-ton ship can't outmaneuver small, fast boats, and the crew has only minutes before armed intruders reach the main deck. Here's the strange twist: commercial cargo ships are not allowed to carry weapons. Any vessel caught with an arsenal on board would be barred from most major ports. So instead of firepower, ships rely on engineering to defend themselves. Decks are ringed with razor wire. High-pressure fire hoses double as water cannons, capable of knocking a person off their feet in a single blast. If attackers still make it aboard, ships fall back on a well-rehearsed last resort, the Citadel. Think of it as an armored panic room built into the most protected part of the engine spaces, with its own independent air supply. Crew members seal themselves inside behind reinforced steel doors that hand tools simply cannot breach. This isn't theoretical. Real hijack attempts in piracy hotspots like the Gulf of Aden have played out almost exactly this way. Crews have retreated into citadels within minutes of a boarding, cutting all power and steering from the bridge before locking themselves in, leaving intruders stranded on a dead, drifting ship with nothing to control. In documented incidents, crews have held out inside sealed citadels for over 20 hours in extreme heat while maintaining radio contact with naval forces, until a boarding team from a nearby warship arrived to clear the vessel and free them, all without a single crew casualty. It's one of the more remarkable facts about modern shipping. Some of the most effective defense on the high seas comes not from weapons, but from a locked door and absolute discipline. But nothing tests a crew like losing power in a violent storm. At the worst possible moment, the main engine can let out a harsh mechanical grind and die completely. Lights fail. Emergency lamps flicker on in long, dim corridors. When a 100,000-ton ship loses propulsion in heavy seas, it triggers one of the most dangerous situations in commercial shipping. Without a turning propeller, the vessel can no longer hold its bow into the wind. Waves can swing the helpless hull sideways within seconds, a position sailors call beam on, or lying in the trough. Picture trying to balance a log on a rushing river. The moment it turns sideways, the current flips it instantly. In a severe beam-on roll, a ship's deck can tilt past 30 degrees, tearing lashings loose and sending stacked containers crashing across the deck. Why does a reliable diesel engine die at exactly the wrong moment? Violent rolling stirs up decades of sediment sitting at the bottom of fuel tanks. That sludge clogs fine fuel filters almost instantly. Air bubbles get pulled into the fuel lines, and the engine's own safety systems shut down the fuel supply automatically to protect the machinery from catastrophic damage, which, in the middle of a storm, creates a new and far more immediate danger. There are documented North Atlantic cases where exactly this happened: total blackout during a winter storm, the backup generator failing to auto-start because the ship's list was too severe, the hull heeled over more than 30 degrees, engineers working on wet, sloping steel plates in sweltering heat with only minutes before another wave could roll the ship past the point of recovery. In cases like this, crews have manually bled air from high-pressure fuel pumps by hand, hot tools slipping in oil-slicked fingers, wave after wave knocking people off their feet, until fuel was pumped back into the system and the generator was jump-started using compressed air. When the main engine finally roars back to life, the propeller bites back into the water, steering control returns on the bridge, and the ship turns its bow back into the oncoming swell, battered, but still moving forward. After 9 months of total isolation, one lesson becomes clear: a ship this size doesn't survive on engine power alone. It survives on discipline. On routine. On 20-odd people quietly doing their jobs, day after day, thousands of kilometers from the nearest shore, keeping a small, self-contained world running against every odd the ocean can throw at it. That, more than any storm or any wave, is the real story of life at sea.